Hey, this is Mr. Barr, and this is transformations, more specifically translations. So let's get going here. Goal: I can manipulate shapes using transformations. Why? Computer graphics are just transformations. I want to understand how software works. When you hear the word translation, what do you think of? Do you think of languages? Do you think of taking a word from one language and moving it into another language? In geometry, the word translate means move. Every movement you see on a computer screen is actually a mathematical translation. Each movement requires math, and we're going to learn about that math today. There are four main geometric transformations: the translation, the reflection, the rotation, the dilation. Today we're going to focus on translations, the moving of an object. So let's get started on our notes. And our topic is translation. So start with your name. And our topic is transformations. But more specifically, we're doing the translation. And translation means move. We're going to move objects. We're going to move shapes. The rest of this lesson is going to be done on a piece of graph paper. So I have a piece of graph paper here, which you can't see because I moved it. So here's a piece of graph paper. And I'm going to start by folding my graph paper. Hot dog. And then hamburger. And then I'm going to unfold it. And notice that made it 1, 2, 3, 4 squares. In this square, I'm going to draw using a ruler. Actually, yeah, or using a ruler. I'm going to draw a coordinate system. So let's draw a coordinate system. Just a moment. Notice when I'm drawing a coordinate system, I'm really making sure that it lines up with the graph paper. So there's the coordinate system, and on it, I'm going to plot point A. And that is at 1, 2. And I'm noticing my points are bleeding through into my background. We're going to translate this. So this is point A. And how are we going to translate this? We're going to translate it up 3 and left 4. So translate, in this box we're going to write translate which is a fancy word for move, up 3 and, was it left 4? Up 3 and left 4. So we're going to take this point, we're going to move it up 3, 1, 2, 3, and left 4, 1, 2, 3, 4. So this point is now, oh, I'm off the page, aren't I? Off the screen. It's now right here. And we call that A prime. The new point and that's pronounced A prime. So we started here, we moved it, translated it up to there, and that's called A prime. So we just translated a point. We can also translate, oh, there it is, A to A prime. We're now going to translate a little line segment. So right here, I need another coordinate system. When I draw my coordinate system, I'm very specifically trying to get it right on top of the graph paper so that the line completely lines up with the grid. There's my coordinate system. I'm going to put point A on it. Point A is at, what, -5, 2. And B is at 1, 4. So there's our line segment, AB. How do we want to move this thing? We want to go down 3 and right 5. So I do each point, point by point. I take A, I go down 3, right 5. I take B, I go down 3, right 5. Down 3, 1, 2, 3, 1, 2, 3, 4, 5. There is A prime. B goes down 3, 1, 2, 3, 1, 2, 3, 4, 5. And there is B prime. And that is my translated line. A prime, B prime. Did the length of that segment change? Once I moved it, did it actually change the length of the segment? No, this segment is still the same length. If I use this ruler, let's see, it used to be about 3.5 centimeters, and now it is, did I mess it up? Or am I just not reading it correctly? It used to be a little bit more than 3.5, and now it is a little bit more than 3.5. Okay, so it did not change its length. A translation does not change the length of the object. So this pen right here, it has some kind of a length, right? If I move it around, is it changing length? No. Translation does not change the size of the object. Translations does not change the length of an object. It's the same before and after. Excuse me. Now we're going to do a full triangle, and we're going to move this up 7 and right 2. So let's get... You can do this on the back of yours. Since I'm using ink or a marker so you can really see it, I can't use the back of mine, but you'll use the back of your page. I'm just going to get another one ready to go. So you're flipping your page over. I'm just getting another paper ready to go here. And let's draw a coordinate system to get started. Really making sure that I'm on top of the grid. Oh, that line's a little bit faint, isn't it? And plotting this point, or this triangle, and it looks like this triangle is at, let's see, this is at -5, -6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. There's A. And then I'm just going to go over 2 to get to C. And it looks like I have to go up 1, 2, 3, 4 to get to B. So there's the original triangle. And now I'm going to take that triangle and I'm going to translate it. How am I translating this thing? I'm translating it up 7 and right 2. So each point goes up 7 and right 2. So let's start with A. 1, 2, 3, 4, 5, 6, 7, 1, 2. There's A prime. Now I can do it, I can do each point, or I can just, now that I have this first starting point, I can just build the triangle off of that. So I know I have to go over 2. There's C prime. And I need to go from the middle of it up 5, right? No, 1, 2, up 4. 1, 2, 3, 4. And there's B prime. Or I could do each one up 7, right 2. 1, 2, 3, 4, 5, 6, 7, 1, 2. 1, 2, 3, 4, 5, 6, 7, 1, 2. So you can either go point by point, or you can just do one point and then build the shape off of that one point. There we go. So now I have triangle A prime, B prime, C prime. So triangle ABC turned into A prime, B prime, C prime. Let's put this here. Translate up 7, right 2. Excellent. That's, I think, it for the notes. Let me check. I think the rest of this is just going to be practice. Yeah, I think the rest is going to be practice. All right, let's start with this. I'm going to take this guy right here, AB, and I'm going to move it around. Is its length going to change? No, it's not. But what is the length of AB? So let's find the length of AB. How did I do that? Well, it's a lesson from Pythagorean Theorem. I turn it into a right triangle. 1, 2, 3. This is 3. 1, 2, 3. This is 4. 3 squared is 9. 4 squared is 16. Add them to get together, I get a 25. The square root of 25 is 5. So this is 5. So if this is 5, when I move it up 3 and right 5, 1, 2, 3, 1, 2, 3, 4, 5. When I move that segment, and it's right here now, okay, after the movement it's right over there, what's the length of it now? Well, it was 5, and now it is still 5. So we use the Pythagorean Theorem. Same type of idea here. I have this segment. I want to find the length of it, and then I want to find the length of it once it's moved. Well, once it's moved, it's going to be the same length. But let's find the length of it, turning it into a right triangle. 1, 2, 3, 4, 5. This is 5. 1, 2, 3, 4, 5, 6, 7. This is 7. So this is going to be 25 plus 49. Which is going to take me to 74. And the square root of 74 is some number, which I'm about to find. 8.6. So this guy right now is currently 8.6. So this is 8.6. And when I move it, or translate it, what's it going to be? It's still going to be 8.6. All right, that's it. So we've just done translations, moving shapes around. Thank you for watching.